Hello everyone. In this present class, we shall do nothing more. We shall learn nothing more. Merely we shall recapitulate a theorem that we have already done in some of our previous classes. Try to remember, on those classes, we have considered the Boolean algebra B plus dot complement, the fourth tuple B plus dot complement, where we have not been constrained to consider the non-empty set B forming the Boolean algebra B having only two members 0 and 1, the additive identity element and the multiplicative identity element. That does imply the non-empty set B has been consisted with some element else 0 and 1. On those classes, we have learned a theorem in which we have learned the commutative laws for the elements in a Boolean algebra, in the Boolean algebra B, the associative laws, commutative laws for addition and multiplication, the associative laws for addition and multiplication, the distributive laws of multiplication over addition and of addition over multiplication, the idempotent laws for addition and multiplication, the identity laws for addition and multiplication, the inverse laws for addition and multiplication, the dominance laws for addition and multiplication, the absorption laws for addition and multiplication, for the absorption laws, these, the De Morgan's laws and the double complement law. For the elements in the Boolean algebra B plus dot complement, where B is non-empty set B forming the Boolean algebra B plus dot complement having more than two elements, that means there are some elements which are not the additive identity element 0 and the multiplicative identity element 1. In the essence of that very theorem, here we shall learn about a theorem in these two element Boolean algebra B plus dot complementation. Two element Boolean algebra means here we have been constrained to consider the non-empty set B forming the Boolean algebra B having only two elements 0 and 1, the additive identity element and the multiplicative identity element. And we shall learn the same theorem again, the commutative laws for addition, for multiplication, associative laws for addition multiplication, the distributive laws of multiplication over addition, distributive law over addition, of addition over multiplication, the idempotent laws, the identity laws, the inverse laws, the dominance laws, the absorption laws, the De Morgan's laws and the double complement law. Why we are taking this theorem in special? The same theorem we have already learned in the Boolean algebra having more than two elements. So why we are taking this theorem special? Because in this two element Boolean algebra B plus dot complement, we shall prove all this theorem in a different way. So we are taking this theorem specifically. Here I shall prove the distributive law of multiplication over addition. and I shall show you how to prove these laws, and the remaining laws I shall skip for you to prove. So let us now see the procedure of a proof would be same, being same for all these laws. So I am skipping and lefting this to you to do yourself. So let us now see how to prove the distributive law over addition. Distributive law of a multiplication over addition is this. Suppose we are considering these three Boolean variables x1, x2 and x3, and the distributive laws tells us x1 into x2 plus x3, this is equal to x1 into x2 plus x1 into x3. We shall prove it.